Hi guys, welcome to Memo's Tutorials. We are continuing with our vectors. Today we are adding and subtracting our vectors, okay? So now, I want you guys to take note of something. I've drawn a triangle here. It's not so beautiful, but I'm sure you guys are going to get the concept. We have triangle ABC like that. So AB, for vector AB is A. I wrote it down there. BC it's B, and AC it's C, like that. Okay, so I need you guys to take note of something. Remember we said a vector, it's any quantity which has got direction and size. So in this case, vector AB, right, we are moving from A to B. It's AB, it's in that direction, it's positive A. So if you happen to say BA, now that you're opposing this arrow, you are opposing the arrow, your vector is going to be negative A. Same applies for CB. Now you are moving from C to B, you are opposing the arrow, it's going to be a negative B. CA, you are now opposing the arrow. So whenever you oppose the arrow, just know that you have to negate your vector, okay? Then the next thing that I want you guys to learn is that for vector AC, we can actually calculate it by saying AB plus BC. AC, we can calculate it by saying AB plus BC, like that. So AB is equal to, AC is equal to AB plus BC. I need you to take note of something. We're starting with the A and ending with the C for AC. Meaning to say, if they ask you for vector AB, you can actually go this route. You can say it's AC plus CB. You begin with the A and it must end with the B. Whatever route you take, it must start with the A and must end with the B. So now, for vector AC, we said it's equal to vector AB plus BC. What is vector AB? It's just A. Plus, what is vector BC? It's a B. So in other words, our C, it's equal to A plus B, like that, okay? What about for vector AB? Vector AB now, we say it's AC plus CB. So our AC, it's C. But CB is going to be minus B. So in other terms, vector AB is equal to C minus B. And this C minus B is also equal to A, okay? It's also equal to A. I hope we are together on this first step. So these are the facts that I need you to know and be familiar with as we'll be working with these vectors, okay? So now, let's move on to the next one. I need to create some space. Okay. So, we are given a question. They are saying, vector P, it's 3, 5, it's column vectors now. And vector Q, it's minus 4, 3. And vector R, it's 1, minus 2. And part A of the question, they said, find P plus Q. Part B of the question, they said, find P plus R. Part C, it's Q plus R. Part D, it's P plus Q plus R. We are adding for these ones, okay? So how are we going to do it? P plus Q, you write your 3, 5 plus your Q. Let me put the equal signs there. Q, it's minus 4, 3, like that. Okay. Now let's add them together. You're going to add the x's on together and the y's together. Remember, at the top, that's where we have our x's. So it's going to be 3 plus minus 4 and 5 plus 3. What is 3 plus minus 4? A plus and a minus, you know, they give us a negative. So it's 3 minus 4 and 8. 3 minus 4 is a minus 1. So it's minus 1, 8. I hope we're together on the first one. That's for A. B, it's P plus R. P, 3, 5. R, 1 minus 2. Okay? 3 plus 1, Now we'll add it on our heads. 3 plus 1, 4. 5 plus minus 2. Plus and the minus, they'll give us a minus. So 5 minus 2, it's a 3. Like that. What about C? Q plus R. Q is minus 4, 3. Minus, it's minus 4, 3. We are adding. So it's Q plus R. Our R is 1 minus 2. Okay. So minus 4 plus 1, that's a minus 3. 3 plus minus 2, plus the minus a minus. So 3 minus 2, that's a 1. So that's for our C there. Then the last one, I'll have to create space. P plus Q plus R. So it's very easy. Just like how we're adding our matrices, we're adding according to their positions, right? So for the last one, let me erase to create space. Okay, P plus Q plus R. P is 3, 5. Q is minus 4, 3. And then R is 1 minus 2. Okay, it's very easy. We're going to add it according to position, right? So we're saying 3 plus minus 4 plus 1. And then 5 plus 3 plus minus 2, like that. Okay, so 3 plus and the minus, they give us a minus. Okay, so it's 3 minus 4 plus 1. Down here, 5 plus 3 is 8 minus 2. Why am I saying minus 2? Because the plus and the minus will give us a minus. So now, 3 minus 4 plus 1. Both we start off by adding before we subtract. 3 plus 1 is 4. 4 minus 4, 0. 8 minus 2, it's a 6. So that's our vector. 8 minus 2 is a 6. So our final solution for P plus Q plus R, it's 0, 6. I hope you guys were together. Now let's move on to subtraction, because I said today we are adding and subtracting our vectors. So let's move on to subtraction. An example where we have to subtract, it's also a column vector. It's also column vectors as well. Let's see how we work it out. Where we are subtracting, here we were adding, right? So we are given vector A, vector B, vector A and B. Okay, so it's just vector A and B. Vector A is 7, 3. Vector B is minus 6, 2. And part A of the question, they want us to find A minus B. Part B of the question is A plus B. Part C of the question is B minus A. All right. So vector A is 7, 3. So 7, 3 minus 6, 2. Okay. So before we subtract this one, I want you guys to take note of something. So whenever you have negatives following each other like this, just know that they will give you a positive. Okay. You have negatives following each other like that, just know that they will give you a positive at the end of the day. So now, on this question, we have 7 minus 6 and a 3 minus 2. Okay? Minus 6, minus that are following each other, they will give us a plus. This becomes 7 plus 6 and a 3 minus 2. 7 plus 6, that's a 13. 3 minus 2 is a 1. So our final solution is 13, 1. Okay? Our final solution is 13, 1, just in case my video is not showing the bottom part. Our final solution is 13, 1. Why am I saying 13, 1? 7 minus 6, it gives us a positive 13. Because the minus and the minus, they give us a plus. 3 minus 2 is a 1. Okay, 3 minus 2 is a 1. So that's our final solution for A minus B. What about A plus B? I'll have to create space, so I'm going to erase this one. So A plus B, so in place of minus, I'm just going to put a plus there. So it's now A plus B like that. So remember, a plus and a minus, when they are following each other, what you get is a negative. A negative and a positive, when they follow each other, the final outcome is a negative. So we are having a 7 plus minus 6 and a 3 plus 2. So a plus and a minus, they're giving us a minus. So it becomes 7 minus 6, and then the other one is 3 plus 2, which is a 5. So 7 minus 6 is a 1. So our final solution is 1, 5. Okay. Our final solution is 1, 5 for A plus B. What about B minus A? B is minus 6, 2. And then A is 7, 3. Minus 7, 3 like that. So now we are having minus 6, minus 7, and a 2 minus 3. Minus 6 minus 7, we're going to get minus 13. It's a negative 13. 2 minus 3, we're going to get a negative 1. Okay. I wish I maintained my A minus B. There's something special between A minus B and B minus A. Let me rewrite A minus B. I'm going to erase our part B of the question. I'm going to erase our part B of the question. I want to put my part A there. I want you guys to conclude something there. When we say A minus B, this is for A minus B, so that's A. And then this is for B minus A. That's for B minus A. So we said 7 minus 6. It becomes 7 plus 6. 3 minus 2 is a 1. So 7 plus 6 is a 13. So have a look at this. A minus B is 13, 1. Okay? B minus 8 minus 13 minus 1. So in other terms, A minus B is equal to minus B minus A. Okay? Remember I told you at the beginning that whenever you oppose the direction of a vector, your answer will become minus of that answer. So if AB was a minus 2p, the vector minus 2p, but then when you say BA, it will become a positive 2p, right? Because you are opposing minus 2p. So whenever you oppose a vector, it's like you are negating it. So A minus B is 13, 1. But B minus A is like you're multiplying your 13, 1 by a negative 1, okay? I hope you guys benefited from this video. See you on our next video where we are going to be doing magnitude and scalar multiplication.